Yeah, thank you for your introduction. So, hello everybody. Uh, Thank you for joining us today. My name is Shuo, and I am co-founder and CTO of Hemera Protocol. So today I think I'm going to give you a brief introduction of what Hemera Protocol does and what exactly is account-centric indexing. And then our DevRel, Shantanu, will go over more practical use case and examples. I think in the end, we will still have time for Q&A, and you can feel free to drop us any questions you you want to ask. Okay, so let's begin. So first of all, I would like to talk about why we create Hemera Protocol. I think I still remember a few years ago when we first get into the Web3 world and started the company, and we are building a CRM tool for the app, and especially the NFT projects. And they were very popular at that time. I think we spent lots of time finding different APIs, RPC calls, and all different vendors provide different certain piece of data, and we try to merge them all together to build a tool. And of course, it's very not a very pleasant experience. I believe many of you may also have the same experience. No matter you are a DApp developer or a protocol developer or even just a personal developer, you will always find it's very hard to get access to full on-chain Ethereum data. And what's more, I think even if you can get transaction level data or event log data, and it's still very hard to aggregate data into the account level. You can also call it user level. I'm not sure how many of you have experience with Web2. I think every single company in Web2 have their user concept, but this is the missing part from the Ethereum world. And I think what's more, I think recently you already see that hundreds of L2s goes live and the apps become more and more complicated. They create a complicated data on chain, and which make the read of Ethereum data even harder. And everyone is saying that we need more users from Web2, but apparently reading blockchain data is the major blocker. I think that's pretty much why we invented the Hemera protocol. I think the Hemera protocol, which is also the account-centric indexing, is here to address those issues. The Hemera protocol is a programmable protocol, and it abstract low-level on-chain data and those smart contract logic, and utilizing the user-defined functions to express new assets and contracts. And this provide real-time updates and enable developers to build a more efficient way and help Web3 team to save lots of time on reading blockchain data. And to explain a little bit more detail, I think you can think of right now, if you use the account-centric indexing, and you will have a user table for all the Ethereum address. I think it's very similar to the logic in Web2 companies like, for example, Twitter. I think in Twitter's user table, there are features like your email handlers, birthday, and it also can have statistics like how many tweets you have, how many followers you have, and even more sophisticated use case, you can have, for example, how many people view your Twitter today, and how many followers you gain or lose in the past week. And that's all belong to the your user table, your user-centric data. And for our use case, if you have a user table in Ethereum world, and features can be, for example, your assets holdings, or it can also be your registration history to ENS, or your forecaster followers, or even about tradings. For example, how many trades you made on Uniswap, and how many volumes you have, and even the P&L you have. All those information can be aggregated into the user level by using Hemera Protocol, which is an account-centric indexing protocol. And I think the cool part about account-centric indexing is that right now you can add your own features. You don't need to use the exist. Of course, we have lots of existing features, built-in features, but you can also create your own features and add it to the user level. You can define your own data structures and you can write your own code. The code here doesn't mean you have to write everything from the scratch. I think you can actually, we already set up most of the framework for you. We already stream all the all the blocks, transactions, and logs to you. And the only thing you need to do is to read the basic data and write your transform logic and generate the data you like. That's all you need to do. And you should be able to run and rerun and backtest with historical data before it actually goes live. I think this part, I think Shaitanu will talk about more later. I think there are lots of benefits you can get from using Hemera Protocol. First of all, comparing with other vendors, I think Hemera Protocol is by default real-time. Since the indexing is along with other indexing work, such as blocks, transactions, you are indexing all the things together. So everything you have will by default be real-time. There will be almost no delay. There'll probably be a few seconds delay, but compared with other tools, for example, Dune, it will be much more real time. I think also it will be automatically aggregate everything into account level. I think the account level will help you in majority of your data use cases. No matter you are building, for example, you are building a DeFi dashboard, you may want to understand each user's behavior. And if you are building a social app, you want to understand different users on your social platform. The account level data can also help you by the most. And I think with the account-centric indexing, it actually covers lots of users use cases on the blockchain. I think from the basic blockchain explorers to, for example, your Web3 wallets, and to your, for example, ecosystem dashboard, and even a more complicated use cases like anti-CPU detections and power user analysis. I think everything on top of the data can be built using the Hemera protocol. And also we are continuously building protocol. We are not stop here. We are actually adding lots of features to the Hemera protocol every day, every week. And I think there are two aspects we are focusing the most. First of all, we want to, you can call it modularity, but you can also call it, for example, abstraction. So we want to make sure the user interface we expose a generic interface, and every single developer should be feel very easy to pick up, and they can easily add their own logic and create their own features. On the other hand is the performance. I think you may also heard several chains, for example, Monad, MegaEase. They claim themselves to be high performance EVM chain. They will have up to, like, let's say 10,000 transactions per second. If that's the case, the indexer will of course need lots of performance optimization. That's another aspect we are working on right now. I think lastly, I think this is all the ecosystem partners we have. And one thing notable here is that we actually start to work with Tycho since testnet. And our social scan explorer is live, I think since the first day of Tycho's midnight. And right now we are still running Tycho's nodes, and we have the Tycho explorer on social scan. And we also have a set of APIs with the full Tycho's data. If you want to use that, we can also get you access right away. Yeah, and of course, our indexer is ready to use. If you have, I think you can just apply Tycho's public RPC, and you will be able to index any smart contract on Tycho. I think there are a few useful links. I think we have the website, which will talk about our, I think, external facing product. I think that's pretty much for blockchains, for the apps. I think if you have that, if you want a professional service, you can just go to our website and check. And I think the most important piece is the doc and GitHub. I think our Hemera protocol is open source, and you can clone the project right away and start to run, I think, on your local laptop. That's all open to you. A few other links. I think we have Twitters. I think Hemera Protocol is our main Twitter. We also have a Twitter called Social Scan. Social Scan is a application on top of Hemera Protocol. I think it's also built by our team, but it's a more application user-facing application. I think that's all from my side. I will hand over to Shantanu, and he will go over the other part of the workshop.
Awesome. Thank you. Thank you so much. I think that was a wonderful walkthrough. So I'll quickly share my screen, if you don't mind. Okay, perfect. So hi, my name is Shantanu. I am a part of the DevRel team at Hemera. And today we'll be walking through a very exciting thing called building UDFs for our dApps. So essentially what we'll be doing is we'll be running our own indexer network. We'll be writing some custom code, and we'll be indexing ES721 on a Ethereum or a Tyco network. So it's very easy, very sweet, and we can get started quickly. But before we move on, there are a few things that I would want to highlight. One is, of course, Shaw has mentioned and spoken briefly about Hemera Protocol, but yeah, a few pointers from my side as well. So essentially, Hemera Protocol is an account-centric programmable indexer network, and it helps blockchain developers build faster applications and get more real-time data on chain data. Um, yeah, so let's talk a bit more about, I'll throw some light on hemera-indexer as well. So specifically, hemera-indexer is the open source code that's available on our GitHub, and you can spin up and run your own indexer network with a custom built code. And that code that actually triggers a particular function, it's called UDF, user defined functions. So the whole goal is you define a specific triggers, you write code depending on what are your expectations and what are your needs are. And then that code takes care of the whole indexing part of the game. We'll have a look at it. I'm just explaining the flow as of now. Any EVM compatible chains can be done, and in this case, we can also index Tyco. So you can use any public RPCs that are available, and you can get started ASAP. So quick features of our whole indexing network. One is you can export entities like blocks, transactions, logs, tokens. And when we say token, I'm talking about multiple token standards, ERC20, 721, 1155, etc. So in this tutorial, in this workshop today, we'll be walking through 721 and looking at how the data gets populated in the database. There are multiple options for output. One is the Postgres is built in the stack. So you get all the data stored in the Postgres DB, and you can view the data directly through the database itself. There are two more options. One is you can get the JSON, and the other you can export the CSVs as well. Depending on your use case, depending on your needs, you can modify the output formats as well. Moving next, setting up is very, very easy. So first things first, we need two things that are really essential is a system on which you want to run the network, and second is the RPC node. So you can get the RPC. You can host your own RPC node, or second, you can get an RPC URL based on the chain that you want to track on or put your UDFs on. So in this case, we'll be putting out Tyco or Ethereum, whatever your needs are. You can put it down. Hardware requirement. There are a few things that we need to keep in mind. One is we need a 4-core CPU. Second is 8 GB RAM, 8 GB memory to power the whole indexing powerhouse that we have built out, and SSD storage to make sure the whole indexing part is sweet and swift, while you are building our applications. But the data size, the size of the SSD depends on the type of application you're trying to build or the type of data that you're trying to index. On our documentation, we have this. I'll just quickly share this documentation. Uh, if we can add this to the chat as well. So in this documentation, in this particular repository, you can have a look at on the data space that is required, and yeah, you can spin out your own node. Perfect. So I think we'll get started. We'll quickly have an overview about how to run this, how to get started, and all of those things. Before we begin, one last thing that I would want to highlight is configuration of our environmental variables. This is the most essential part because without this, the whole network might face some difficulties in getting configured. So there are a few things that we need to take care of. One is the RPC URL, which goes in the environmental variables file, env file, which we call. Then we also have the blocks from which we want to get started with. So we have mentioned somewhere around 200K block number, and from starting from that block, the indexer network will start indexing the data and putting out based on your output format. And then you have a set of more configurations like Postgres SQL DBs, credentials, and etc. things. So yes, I think I'll quickly share my entire screen and I'll showcase the whole working on how to set things up. Okay, perfect. So this is a repository which is called hemera-indexer, and in this we have like a specific use cases that we have built out. And in today's example, we'll be looking at the mint date for each token within ERC20 smart contract. So the code is open source. You can check this out right after the session as well. So first things first, you have to clone this repository. I have already cloned the repository and it's there on my system. And then you have to just get into the Hemera network indexer and then get into Docker-compose. So this Docker-compose, the directory, it contains like two set of files. One is at docker-compose.yaml, which is Docker composition logic that is written out. All of the services that needs to spun up to run our indexer network is configured in this file. I would encourage not to actually tweak this file. This is an essential file which takes care of all the rendering, all the services that runs behind the scene of our indexer network. Next file, if you can see, there is a hemera-indexer.env, which holds all of our environmental variables. So to quickly check that, we'll do nano or vim, whatever is preferable. We'll just quickly go here. First thing, if you can see, I have a mainnet RPC.
Shantanu, sorry to interrupt. Can you just zoom for your terminal and all the
sorry.
Yeah, thank you.
Okay, perfect. Yeah, so for the provider URL, this is the RPC URL that we are providing here. If you can check, I'm using Infura here, but you can use Anchor, you can use QuickNote, depending on your use cases. And yeah, then you have the start block from which you want to start the indexing process. So we have mentioned somewhere around 200K, and you depending on your use case, you can tweak it out. And then we have the Postgres URL. This is, we can generate it pretty easily. Then you have Postgres details, which is username, password, and DB details. So yeah, these are the essential parts that are required to start the whole indexing network. And once you do that, just go back to the terminal and type Docker. So I'm using it on a Mac OS, and if you're building a project internally or locally, you can use Mac OS. You can use your own. You can host it on a VM as well. But if you're hosting on a VM, on a Linux-based VM, make sure you use sudo command because it requires root access to run all of those services. Again, there are two ways to run the whole of our services. One is the Docker way, which is easy and quick to get started with. The other way is to build from scratch. So we have a Python whole repository, the hemera-indexer repository. You can just build it in the traditional way and get started as well. If you want to tweak something, if you want to check, as Shaw was mentioning, backtrack few things, see how things are working across or what services or what functions are being called internally, I think that is the best way to get started with. But if you just want to play along with the UDFs, configure something of your own and then get started, I think this is the best way to do that. So the next command that we use is docker compose up, and it should take a few time. And perfect. So this has started up based on all of our details that we have. Now, I will let this run for some time to start the indexing processes. But in the meantime, let's quickly browse our code and understand what are the things that we need to inculcate to make sure to write our UDFs. So in that case, at this point, in this case, we are writing a few. I mean, as we mentioned, right? We want to extract the date of a particular mint of a contract that has been done, ERC 712. So first is we write the token mint job. So this is like a function that takes care of what token or what contract you want to track out, and what are items that you want to track out. Let's say I want to track out the date, I want to track out the transaction ID, a few more items that are there on chain, and you want to track that out or index them up. You can actually describe all of them here. So yeah, so as you can see, I have a token mint function which is calling all of those essentials, which is block stamp, token ID, transaction hash, etc. So this file, we need to put that out inside a module. So if you go on inside modules, then you need to go inside customs. You need to create a custom folder, and inside that, the UDFs, which is the user-defined function for which you want to run things out. So here it is ERC712 token mint, and inside that token file, we have a job file which takes care of all the extraction side. This is an essential part, and all of these code is open source. Right after my session, I'll share the code as well, and you can have a look at it as well. Next is a token mint file which goes under the models, which is basically you're defining how would the whole data table would look like. So end of the day, we are putting this data somewhere, right? It could be your output, it could be your Postgres DB, or it could be a JSON file. So, but you need to define the structure of the data in which you want it to, you want it. So one is I'm putting on my table name. If you can see, I have a class which defines a table name. I have a couple of parameters, couple of columns that I've created: token address, token ID, block number, block timestamp, transaction hash, and a few more time-based and a boolean as well. So these are a couple of things that is essential because you need a structured data, right? Unstructured data converting into structured data, that is the case. That is what Hemera is for. So this is an essential part, and this file goes right inside models. So you just need to go to the indexer file, indexer repository. In that, you'll find a folder called common, and inside common, you'll have something called models, in which you'll have all of these files. Then finally, you need to define a data class, and all of these things are on our repository as well. If you want to read more about it, if you want to know more about it. So this is.
Sorry again. We need some zoom. Yeah, thank
you. I think something is wrong with my system, but yes, yes. So this is a data class that you need to write to make sure all of those data is being tracked out. And yeah, I mean, after this is done, you just need to run the network. I'm already running it. So yeah, the network is being running out. But yeah, we'll quickly check for the DB. So I'm just connecting my Postgres and see if this works well. Okay, perfect. So there are a few things that I wanted to talk about. So one is what I'm showing you right now is my Postgres DB, which is running inside my Docker network. So this DB actually consists of the table and as well as the data that we're trying to index right now. So we'll have a quick overview about the data. So if you look at ERC712 changes, it's still being indexed. But yeah, these are few records that are being done. And if you look at the ERC20 transfers, ERC115 transfers, based on the contract that we have provided, it is tracking things out, it is dumping them down into the DB. Now you have two options. And if you want to integrate this data or if you want to use this data in your application, how do you do that? Option one is you use the Hemera's pre-built APIs, which already comes packaged with the indexer node that you're running or the network that you're running. So that is one way to do that. Or the other way, you already have the data dumped into a Postgres. You create. I'll just zoom in again. I don't think I can zoom this particular application, but yeah. For if you want to use this data directly into your application, let's say you want to connect, you can just connect this using any of the Postgres libraries for your native application and start the process. So yeah, I mean this is how the whole indexing part or UDFs part works. So these piece of code, these three files are essentially UDFs, user-defined functions. We are defining a set of functions for our indexer network to perform these XYZ actions. And based on that, it is indexing the data, chunking it out, and putting out in the output that we define. So yeah, this is the whole quick gist about how things work. Yeah. So I'll just again share my workshop screen. Okay, perfect. So I'll share this repository as well. You guys can have a look at it. And yeah, so turning out again, what is UDS? UDS essentially allows users to create their custom functions for a Hemera indexes. UDFs essentially are the custom data operators, and they don't really play along with the existing core code that's there for the network. So you don't have to modify the core concepts or the core protocol code. You just have to put out these functions, put out these piece of code, and you're all good to go. To get started. So if you want to get started with all of these processes, very easy. You just need to get started understanding how what ACI is, account-centric indexings, understand how the whole protocol things work. The link to the docs is docs.hemera.com. I'll drop it in the chat as well. So you can have a look. And if you have any questions, you can reach out to me on at coderpanda at the coderpanda on Discord. I'm also on Tycho's Discord. Feel free to reach out to me if you have any questions. So yeah, that's all from my side. Let me know if you have any questions. I'd be happy to answer.